penta, hexa, hepta, so on and so forth. Ionic, you don't use prefixes, but you do have to put in subscripts. And to use those subscripts, you have to understand what the charge or the oxidation state of that ion is. So the first step, okay, is we have to identify the metal and the nonmetal, and we've got to know its oxidation state. Okay, so to do this, I'm going to put aluminum, and I know that aluminum is in group 13, so it's got 3 valence electrons. Now with those valence electrons, since it wants to get to 8, only has 3, it's going to be a positive 3 because it wants to lose those and become more positive. So you have a nitrogen or nitride. Nitride is just nitrogen. It's just written as a name, so you have to abbreviate it and change the ending to an IDE. Nitrogen is in group 15, so it has 5 valence electrons. So it wants to gain 3, and it so happens it's going to gain those 3 from the nitrogen. So it is it's going to gain those 3 from the aluminum. I'm sorry. So it's going to gain those 3. So when you have this, you have a positive 3 and a negative 3. Here in rule number 3, I say use the crisscross method. Well, I taught you that on a different podcast. So what we're going to do is we're going to take this 3 and we're going to pull it down there and take this 3 and put it down there. So it's going to be AL, and then you simply write in, because a 3 and a 3 reduce down to a 1-to-1 ratio. So that means you need 1 aluminum and 1 nitrogen to get aluminum nitride. So now let's apply the same principle to these other ones that we have. So we have tin. Okay, this 4 is how you technically name a transition metal. This 4 is the charge on the tin. So tin is SN positive 4. First one's always going to be positive, and the second one is always going to be negative. And then phosphorus is going to be a negative 2. It's in the same family as oxygen. So we know that it's going to be a negative 2. So then we simply take these charges and we attach them to the opposites. Okay. So we do that, and we do that. So we take the 4, we put it with P, we take the 2, we put it with ESN. So our chemical formula is SN2P4. And 4 says reduce if necessary. So we can reduce this to SNE2. Next one. Alright, here we go. So cobalt is CO. Its charge is a positive 3. Iodide is iodide is iodine. And it has a negative 1. So again, we're going to flip the charge. So the 1's going to now become attached to the CO, which we don't write it because we already have 1 written. And the 3 has to go with the I. So we put an I and then we put a little 3. Okay. Next one's going to be a little more challenging because there's not going to be an even number. So lead has a charge of positive 4. Again, when you're naming a transition metal, you have to give it a charge. That's why these are in Roman numerals. Nitrogen is going to have a negative 3. So we're going to put the 4 there. We're going to put the 3 there. So it's going to be PB3N4. These can't reduce, so we just simply leave it as that. Okay, now let's look about some standard metals. Some alkali metals or alkali earth metals are going to have a standard charge of 1 or 2. So magnesium is going to have a charge of positive 2. Fluorine is going to have a negative 1. So we flip just the number. The charge goes away. So Mg, we need 1 of them. And then fluorine, we need 2 of them. So we got magnesium fluoride. So these are my answers. This is the work. So sodium, A, is going to be a +1. Carbide, it's a little tricky, but it could be a non-metal if we needed it to be. So it's going to be a C. It is a -4. because it could be a plus or minus 4. It's indifferent. Since you have a positive here, this is going to be the minus. So we flip them. So we got Na. We got to have 4 of those for every 1 carbon. So this 4 goes to the Na. The 1 goes to the C. Okay. So that's how you take a compound, a formula, and associate it with its name. Okay. Now we're going to look at some ternary ionic compounds, which means we have to use the polyatomic ion sheet because they're polyatomic ions. These up here were binary, so they were just between 2 elements. So let me move this out of the way real quick. All right. So everything can be seen. So we're going to write barium. Our chemical formula is Ba for barium. And then we're going to find chlorite on this sheet. Well, barium has a charge of +2. So chlorite has a charge, since it is in this -1 column, it's going to be ClO2, and then it has a charge of -1. So then we're going to flip up our charges just like we did on the top. So it's going to be BaClO2 parentheses. This 2 goes right there. Little 2. So this little 2 means that we have to have 2 chlorites to balance out the charge of that barium to absorb both of those valence electrons that that barium has to give away. So the next one, sodium. Sodium has a charge of +1 because it wants to give away its only valence electron. And then we're going to find bicarbonate up here, and it is HCO3, and it has a -1 charge. So since we have a +1 go into a -1, we simply drop the charges when we write it, and we write it as that right there. Both of them have 1. So manganese 2 peroxide. So let's start by writing manganese, which is Mn. Its charge is a +2. Since it's a transition metal, it's going to be listed. And then let's find peroxide, which is simply going to be O2 with a -2 charge. Since you have a +2 going to a -2, it's the same number. It's a 1-to-1 ratio. So it's just going to be MnO2. Okay. Next one, lithium. So Li is a +1 charge. We find chromate on this chart. So chromate is going to be Cr(O4), and it has a -2 charge right here. So we take the charge, we flip it to the element that it's attached to, or the compound. So we've got Li parentheses CrO4 parentheses. We put a 2 Li since the chromate has a -2 charge. Zinc, again, charge of the transition metal is going to be listed. So +2. Iodate. So let's find iodate, which is going to be an IO3, has a -1 charge. We simply flip them, so that means we got 1 Zn, and then we have 2 iodates, or IO3s. Potassium. Potassium is a +1 charge. Perchlorate is going to be a ClO4 -1. Perchlorate's right here. It's in the -1 column, so it has a -1 charge. 1-to-1 ratio, so we simply just write it as such. We just drop the charges away. Copper is a +1. Transition metal is going to be listed. Silicate is SiO3, and it has a -2 charge. So we flip all of that. So it's copper 2 SiO3. So that's how you take the name of a ternary ionic compound and you give it a chemical formula. So now let's work opposite. Let's take the formula and let's give it a name. So let's expand upon what we know. So we're going to start with binary because they're a little bit easier. So we're going to start with a fairly simple one. Be is beryllium. So again, we capitalize the first name, beryllium. We take the chlorine. Instead of saying chlorine, we just simply call it chloride. Beryllium is not a transition metal, so we don't have to do anything special to it. Okay. The next one's going to be rubidium. Rb is rubidium. Rubidium nitride. Rubidium is not a transition metal, so we don't have to get it a charge in the form of a Roman numeral. But the next one we will. Titanium. Now titanium is transition metal. Okay, well let's name it. Let's put the parentheses there, and we'll figure out what goes in the parentheses here in a second. So then we know that S is sulfur. So let's change it to sulfide. So it's like we did on the other one with the swap and drop. We have to figure out what the charge is on the titanium. Well, since we have one sulfur, it is a -2. Our titanium has to be a +2 because we have the overall charge of this compound has to be 0. So titanium has to be a 2. So let's put a 2 in the numerals. So now we've got copper. Let's put a parentheses. Phosphide. And we're essentially going to do the same thing, so that we know that we have 2 phosphoruses. Each phosphorus has a -3 charge. So 3 times gives us a -6. So these 3 coppers have to be a +6 because the overall charge has to equal 0. So each copper has to be a 2. Next one is lithium nitride. Nothing special about it because it's not a transition metal, so you just simply name it as it's written. Same thing with the next one. It's going to be sodium oxide. This one, lead, is technically considered a transition metal, so we're going to give it a charge. So since silicon is a -4, we're going to make lead a +4. So we're going to flip the charge. And then we've got nickel. Again, nickel is a transition metal, so we have to assign it a charge. Iodide. So we know that one iodine is -1, and we've got 3 of them. So we've got a -3, so we know our nickel has to be a +3 for its charge. So that's how you take a chemical formula and you give it a chemical name. Again, if you use a transition metal, you have to put the charge in parentheses or it's not going to be correct. Okay? And we're going to essentially do the same thing for the ternary ionic compounds. So I'm not going to do those with you because you have the polyatomic ion chart. Hopefully you get a better understanding of how to name binary ionic compounds and take a name and give it a chemical formula. So we're going to do a few